Hello everyone, so today's problem is find the maximum sum of node values. There exists a undirected tree with n nodes and numbered from 0 to n minus 1. We are given a 0 index 2D integer array edges of length n minus 1, where edge of I is equal to u of I and v of I. What is u of I and v of I? We'll find it. Indicate that there is an edge between node acha, that is node u and v in the tree. We are also given a positive integer k and a zero-indexed array of non-negative integers nums of length n, where nums of I represent the value of node numbered I. So Alice wants to sum of values of tree nodes to be maximum, for which Alice can perform the following operations any number of times, including 0. Choose an index uv connecting the nodes u and v and update their value as follows. Nums of u is equal to nums of u or x or k. Nums of v is nums of v XOR k. So let's suppose this is the edge u and v. So if you want to XOR this, k is given as 3. So you have to XOR this as well as XOR this. We have to XOR both of them. You cannot individually XOR one of them. In an edge, there are two connected nodes for an edge. So you have to XOR both of them. You have to return the maximum possible sum of the value Alice can achieve by performing the operations any number of times. So let's see the examples. We are given nums 1 to 1. This is the value of the nodes and k is as 3. This is the two edges given to you. This is the pictorial representation of the same. So this is not the value, this is the node number. So 0, 1, 2. So for 0 node the value is 1. For the first node its value 2. For the second node's value 1. So I've drawn that particular graph with value and not with the index. So this is 1, this is also 1. So if you see, this is value 1, this is 2, this is 1, and this is 1. We want to maximize this. So if you take this particular node, if you take this particular edge, and if you try to XOR it, we have to XOR this both. So let's XOR this both. So 1 XOR 3 is, so 1 is 0, 0, 1 and 3 is 0, 1, 1. So if you XOR this, it will become 0, 1, 0, which is 2. So this will become, the value after XOR will become 2. This, if you XOR 2, 2 XOR 3 is, so 2 is 0, 1, 0, 3 is 0, 1, 1. So it will become 0, 0, 1. So this will become 1. So after this, can we XOR this? We can XOR this. So we'll XOR this. So 1 XOR 3 is 2. We are already calculated it. And if we XOR this, we have to XOR the other node as well. So if we XOR 1, it will become again 2. So after XORing all the nodes, these two edges if we XOR, we get 2, 2 and 2. So if you add 2 plus 2 plus 2, which is 6. That is our answer. So let's see the test case number 2. So this is the tree, indexed tree, and this is the value tree. So if you XOR this with k is 7, so k7 is 1, 1, 1, 3 is 0, 1, 1. So if you XOR this, it will become 0, this will become 4. So if you XOR 2, because if we XORing this, we have to compulsorily XOR this as well. So this will be 0, 1, 0. So it will become 1. This is 0, this is 1. So this is 5. So this will become 5. So as you can see, both the values have increased, and that now if we calculate the summation, it is becoming 9. So that is our desired result. So in the first example, we directly did XOR to all the numbers. As you can see, if you did this, you have to do this. If you do this, you have to compulsorily do that. So let's see if we can derive the same thing. If we can do something by XORing all the numbers, or we cannot XOR it. So let's see. So if you XOR 1, it will become 2, as we have already seen. If you XOR 2, it will become 1, and if you XOR 1, it will become 2. But there is two edges, so you have to XOR this as well again, so it will again become 2, as we have seen in the test cases. So if we take any two nodes, and if can we XOR this both without changing this? Yes, we can. Let's see the other example. So if you want to XOR this and this, rest I don't want to XOR for now. I only want to XOR this and this. So if I XOR this, so it will become 1 XOR 3, and this will also become 1 XOR 3. This has to be XORed because this is connected to this node, so this will be 2 XOR 3. And if this is XORed, we have to XOR this as well. 2 XOR 3. This will XOR also because this is connected to this. 4 XOR 3, and this is connected to this. Again we have to XOR this because this node is also connected to this node, so we have to XOR this once again. So XOR 3, and this node is connected to this, XOR 3. This node is connected to this, so XOR 3, and this node is connected to this node, so I am not going to write for that. I'm just writing for this particular path. So this will become 2. This is 2. This, if I write it correctly once again, this is 2 XOR 3 XOR 3. So 3 XOR 3 is 0 because 3 is 0 1 1. Again 3 is 0 1 1. So if you XOR this, it will become 0 0 0. And 2 XOR 0 is 2 is 0 1 0 0 0 0 0 is 0. So it will become again the same thing. So anything XOR 0 is that same thing. So I can remove this. This is unchanged. I can remove this. I can remove this because there are two XORs here. So if you see, we have successfully changed this to, uh, and the others are still the same. So this is a very important observation that we made. So if we generalize this, if there is a node S and there is a node R, and we want to XOR this as well as this, we have to take two, which is a pair. We need to do XOR to a pair and not a single node, because if you do a single node XOR, it will change the complete tree. But if you take a pair of nodes, you don't change any of the nodes. So let's suppose we take this, so it will become K XOR suppose X we have taken as the, this will become Q XOR X. This is R XOR X, X XOR X. Again for this it will become XOR X XOR X. So this will cancel out. This will also cancel out. So these intermediate nodes are the same, but we have successfully XOR the end nodes. So in the question it was given that Alice can perform the following operation any number of times. So it could be 1 to any number of times, which means it can be infinity. But do we need to perform till infinity? Let's check. So let's see the property of XOR. So if you XOR any number by itself, it will be always 0. And if you XOR the value with 0, it will always be the same value. So it will not change. So XOR of A is 0, and 0 of X is X. Okay, let's see. This is 0. This is 0. 0 XOR 0 is also 0. So this will become 0. So X XOR 0 is X. So this will become X. this will become 0. 0 XOR k is k, so this will become 0. X XOR with 0 with X XOR with k is k, and k XOR with x is k XOR with x is XOR itself. We cannot reduce it further. So as you can see, if you have given, if you have taken k n number of times where n is even, so it will reduce to 0, or you can say it doesn't even change, because after XORing x with 0 it will be x. Or you can say that if you XOR it odd number of times, which is 3 here, you will have to XOR only once. So as you can see, if you take any number of, n is number of k, so if you take any number of k, you either applied 0 times or you either applied 1 time. As we have already seen that if you want to XOR a value in a particular tree, you have to take a node which is not that. That means we have to create a pair, and in pair only we have to perform the XOR operation. So we need to perform at most one XOR operation, as I have explained, only 0 times or 1 time. 0 is this where we did not apply XOR, and 1 is this where we applied XOR. And XOR can be applied to pair of nodes which will not affect the other nodes. Why we are taking in a pair? Because it will not affect other nodes, as we have explained before. So let's see what will be the algorithm. Let's do a dry run, then I'll explain you the code. So let's do the XOR to all of them. So this is the XOR table, you can say, where XOR value n is 0 because we did not XOR it here. We can take XOR is equal to 1 because we can only apply XOR 0 times or 1 time. So we have already XORed it 0 times. Now we'll calculate it for 1 time. So, but can we say that the sum will will always be greater than or equal to this sum? Yes, because if we sum this is 2 to 4, 8, 10, 12. So this is 12. So if we XOR this, and if you get less for this 4, if you get less value, would we XOR it? No. So minimum the value of sum can be 12. So we'll see if we can increase this by doing XOR to some pairs of values, because if we do a pair XOR, it will not affect the others. So let's do XOR of all the values. XOR of 2 will be 1. As we have already seen, this will be 1, this will be 7. 0 1 1 is, so 4 and 3 XOR will be 1 1 1, which is 7. XOR of 2 is 1, XOR of 1 is 3, XOR of 1 is 3. So if you see, if we XOR, if I move this here, so minimum sum is 12. So we'll see if we can increase that. So if we XOR 2, it will become 1. So similarly, if you XOR 4, it will become 7. So I'll find the net change in the XOR table. So it was 2 before and it got 1. So it reduced by 1. It is 1 now. It was 2. It will become -1 because 1 minus 2 is -1. It is 7. So we increased by 3, 1, and we decreased by 1, increased by 2, and increased by 2. So if you see here, some values have indeed increased and some values have decreased. So can we take this values and not take these values? Yes, we can, but we have to take it in pairs, because if we don't take in pairs, we will affect the other nodes as well. So if we take these two values, it will not affect any other values. So if we want to select pairs from this array, we can do it greedily using sorting. So if we sort this array 3, 2, 2, -1, -1, -1, we have to collect pairs from here. So this will be one pair and it's indeed greater than 0. If it's getting 0, we won't add because it doesn't make any change. So we don't take, we only take pair value which is greater than 0. We cannot take this pair because this will be XOR 3 times, which will change the tree. So we have to take other pair. This will give you 2 comma minus 1, which is a positive value 1. We will take this pair as well. We'll take this pair. So the other last pair is minus 1 comma minus 1, which will give you minus 2, which is less than 0. So we'll not take this pair. So after performing the XOR once, we increase the value of this node by 3, this node by 2, and the subsequent sum by. So we increase the sum by 5. So we can add plus 5 because we increased this values, and we can also add 1. So it will be 17 plus 1 is 18. So the maximum sum you can get from this array is 18. So let's see the algorithm. So I have made new array for storing the uh, XOR 1 values of all the nodes. I've created this sum. Initially it would be nums of I, summation of all the numbers in nums array, and we'll fill the new nums which is XOR of 1. We have to calculate the profit, or you can say the net gain. So the net gain will be, as I've explained you, the XOR minus the original value. So we have done XOR minus the original value. XOR minus original value. So we'll sort that in descending order. That's why I've written collection dot reverse sort. And we have to collect pairs. So pair, this is the, if I show you this, we'll take this only 3 2 2 minus 1 minus 1 minus 1. 3 2 2 minus 1 minus 1 minus 1. So we are at high, so we'll take I plus 1th index, and we'll jump to I plus 1th I plus 2th index, because this is 0 1 2 3 4 5. So if we have taken this pair, we cannot take this element, so we have to directly jump here. So we have to increase I is equal to I plus 2. That is what I'm doing here. I'm incrementing the I value by 2, and I'm adding index I and index I plus 1. Then net profit is greater than 0, which means the value of the number is increasing. Then I'll add that to my sum and I'll return. So this is the complete solution. Then link to the notes and the PDF code will be in the description. If you have any suggestions, make it down below in the comment section. I'll read and try to improve. Thank you.